This is our second video that goes with this lesson. In this lesson, we're going to be talking about standard form. When we talk about standard form, this is the equation we're talking about. ax squared plus bx plus c. As we go through this unit, there will be some times when standard form will be the easiest thing you can do. There will be other times when a different form might make things easier for you. So we have 3 different forms. Each form has its advantages and disadvantages. So let's take a look at what some of these things are. If I have this function, sometimes it's going to open up, sometimes it's going to open down. Let me show you what I have on Desmos. So here I am on Desmos. You can see I have my function here. Right now my a is at 1. If I make that a value larger, notice what happens. It's getting skinnier, right? Okay, then what happens when I get down lower? Let's say specifically between 0 and 1. So here we are at 1, and if I go down lower, it's getting wider and wider and wider and wider. And then when I flip over to the negatives, what happens there? The parabola itself flips over. Okay, so I'm actually going to set this in motion so we can see it. So it gets really wide, gets really narrow, and then wide again, and then flips over. So, okay, so on our paper, the parabola is going to open up if a is greater than 0. However, it's going to open down if a is less than 0. So if it's basically positive, it's going to open up. If it's negative, it's going to open down. If it opens up, then it has a minimum point down here. If it opens down, then it's going to have a maximum point. Okay, axis of symmetry and how do you find it? Remember I said a second ago that some things in standard will be easier and some things in other forms will be easier. Axis of symmetry in quadratic in standard form is not super easy. We're going to use this formula. You need to have it memorized because it comes up a lot in mathematics. You're going to have the formula x equals negative b over 2a. That is the axis of symmetry. X is your axis of symmetry, is negative b over 2a. Remember, the axis of symmetry is the line that cuts it in half. So it's the line that divides that parabola in half. That is your axis of symmetry. How do you find it? Negative b over 2a. We will do some examples. Now, what is the vertex and how do you find it? Well, the vertex, we saw this in our last unit, our last lesson, that the x value comes from this negative b over 2a. But then the y value, to find the y value, what I do is I plug that negative b over 2a, I plug it into the function, and I work it out. And we'll do some examples. How do you find the y-intercept? The y-intercept is easy. Let's go back to Desmos for a second. Okay, notice right now where my y-intercept is. Look at my a, b, and c numbers. What if I move some things around? What if I want to drag this upwards a little bit? The way I'm going to do that is I'm going to set this one in motion. And so now it's at 4.72. Y-intercept is at 4.72. Notice it's not the vertex. So I'm going to let it come back down. It's not the vertex which is determined by the c. Remember, the vertex is negative b over 2a. So our c value is telling us what is the y-intercept. And because it is a point, we always use a coordinate. 0c is our y-intercept. All right, let's look at some examples. You might take a second to number your axes, just because that might make it a little bit easier for you. I did that. Okay, some of the stuff we can do without even doing any math. We can just look at it and we know. So does it open up or down? Well, it's negative, so it opens down. If it opens down, that means it has a max point. Okay, vertex. I can't actually find the vertex yet until I find the axis of symmetry. And so I'm going to come over here and do some scratch work to show you what the axis of symmetry is. I'm going to take x and set that equal to negative b over 2a. So I plugged in negative b, that's 4, over 2 times a, that's negative 2. And that's supposed to be an equal sign. And so it's negative 4 over negative 4, that's 1, right? So my axis of symmetry is x equals 1. I'm going to take a second and put that on my graph. Okay, so here's my axis of symmetry. Now, for my vertex, I take that number, and that becomes my x value. But then I take that number to find my y value. I take that number and I plug it in. So I'm going to take that 1, I'm going to plug it in. Notice I'm using parentheses. You want to use parentheses when you plug numbers in, or else you're going to lose some negative signs. So make sure you do that. Also, make sure you follow order of operations. This first step here, when we do it, we do 1 squared, and that's 1, and we take that times 2, and that's -2. So you can do this on your calculator, or if you want to do it in your head, you can do that too. And I'm getting -3 for that. Do you get -3? So my vertex is going to be on the axis of symmetry at -3. Okay, and then that is the answer to what is my min or max value is -3. That y value is always my min or max value. Now, my y-intercept, that's always the number on the end. That's the c. That's 0, -5. So I'm going to come down here, and I'm going to go to 0, -5, and I'm going to graph it there. Now remember, the name, axis of symmetry, tells us that we have some symmetry. So in just a minute when we draw this, we're going to come over here and make a symmetrical point over here. Okay, domain and range. Domain is always -infinity to +infinity on a parabola. The range goes from the minimum or maximum value to infinity. And the question is it opening up or opening down? So I'm gonna wait. I'm gonna answer that question. Well, we can see it here. We're almost there. So it's going to go from -infinity all the way to -3, and it does include -3. So I put a square bracket on that one. Okay, let's finish drawing our parabola. We have 3 points because we had the vertex and we have the y-intercept. That really is enough for a rough sketch. Now we should have more points when we move on, but for now, this is enough for a rough sketch. So my parabola is going to look something like this. And that's going to help me answer the rest of these questions, because how many solutions does it have? It does not have any. Didn't hit the axis. Which means it does not have any x-intercepts. Where is it increasing? Okay, it's flipped upside down. So now it's flipped upside down from -infinity all the way to 1, +1. It is increasing. And then from 1 to +infinity, it is decreasing. Remember, that's where I was talking about, like you talk about the x values on those. So it's increasing from -infinity all the way to 1, and then it's decreasing from 1 to infinity. Okay, and finally, end behavior. When x is approaching -infinity, that's on the left-hand side, it's going down to -infinity. When it's going to +infinity on the right-hand side, it's also going to -infinity. On parabolas, those will always be the same as each other. Let's take a look at one more example. Take a minute to pause it here and see what you can answer. Okay, let's see what you have so far. It is going to open up. That means it has a minimum point. The vertex is -b/2a. I do that, I get a -2. And my axis of symmetry, I'm going to plug that number in and I'm going to work it out. Which, when I do that, looks to me like that's going to be 0. Because I have a +4, a -8, a +4, that adds up to 0. So my min-max value is 0. And so I know that I have a point there at -2, 0. Okay, y-intercept. I have to go back to my equation. My y-intercept is just the number on the end there, the c. So that is 0, 4. That's another thing that I can easily plot on my graph. And if I know that, then I can come over to the other side and plot one over there as well. The domain on a parabola is always -infinity, +infinity, and then the range goes from that minimum maximum point all the way, whichever way it's going. And again, if we were drawing this for real, we would want to have 5 points, but right now we have 3 points, and that's enough to get us started. So my range goes from 0 to infinity. And I made a little mistake. I want to make a square bracket there on my 0 because it does include that point. Okay, number of real solutions. It does have a solution. And that solution, or that 0, so solutions and zeros are synonyms, and that is at -2. So let's just go ahead and say -2, 0. Which, coincidentally, is also the vertex. That happens sometimes, not all the time, but it does happen sometimes. Okay, where is it increasing? Where is it decreasing? Those are the x values, and it is increasing from -2 to infinity. and it is decreasing from negative infinity all the way over to negative 2. So this pink area is where it's decreasing, this blue area is where it's increasing. Okay, on parabolas, the answer to the end behavior is always the same number as the other one. So on the left-hand side, it's going to positive infinity. On the right-hand side, it's also going to positive infinity. All right, that is a real quick introduction to standard form. When we get to class, we will do some practice with these.